In this video, I want to talk about why the tangent function looks like it does and look at its key features. So we got a couple of key points here which I can plot. You'll notice I'm actually not going to put a scale on the y-axis. And if you remember, the reason is I'm eventually going to get very, very large values for the tangent function. So anyway, you can kind of look at the table here, some of the different values. Basically, so at 30 degrees, well, first of all, tangent of 0 is 0, so you've got a point right there. And at 30 degrees, the tangent's at like 0.577, and at 45 degrees, it's at 1, and at 60 degrees, it's at 1.73, so it's like up here. And anyway, if you remember, we got very, very large values very quickly once we started getting close to 90, like 85 or so, we're starting to get values that are way up here, this sort of thing. And if you remember, the function wasn't actually defined at 90. So we kept getting closer, basically, as we got closer and closer and closer to 90. If we did like 89.9 or 89.99, we kept getting higher and higher and higher values. But at 90, the function doesn't actually have any values. And what this function does, it approaches something called an asymptote. This function is going to get infinitely high as we get closer and closer to 90. And it will become almost vertical. Not quite, but almost vertical. But it'll never actually cross that line. And that line has a special name. It's called an asymptote. Okay? An asymptote is basically a line that a graph approaches. Usually graphs don't cross asymptote lines. Usually they just get closer and closer and closer to it. Okay? For the negative values, you actually have the same general shape, except all the values are negative. So the tangent function is going to approach a negative asymptote at negative 90, okay? And the graph looks like that. It kind of looks like the cubic function, if you've ever seen y equals x cubed. It's not the same shape, but it kind of looks similar, okay? Now, if you went to the unit circle and you started finding other trig values for, 180 degrees, 135, and other values, what you would find out is tangent of 180 is also going to be 0. You're basically going to see the same shape with the asymptote repeating again and again, okay? It's basically going to have an asymptote at 90 and 270 and at negative 90 and so on. And you're going to see the same kind of thing happening back here as well. The function's going to do this sort of thing, okay? So the tangent function is a periodic function. It repeats the same pattern over and over and over again. However, there are some pretty big differences here. First of all, notice this thing does not have an amplitude, okay? It goes up infinitely high, it goes down infinitely low, so we don't have a high point or a low point, okay? It's got another feature that the other trig functions we talked about doesn't have. It has these asymptotes, okay? These lines that the graph approaches, okay? It does have a period, but if you notice, the period's not the same as the period for the sine function. That's only 180 degrees to go through one cycle, okay? And you notice it's another 180 degrees to go through another cycle, okay? So the period's 180 degrees, or pi radians if you're working radians, not 360 degrees like it is for sine and cosine function, okay? It does still have a midline, okay? We'll cross through the axis like that. Again, it crosses through the origin. That's a good thing to know. The transformation patterns that we've worked with before will still apply. The graph will get steeper. It won't have an actual amplitude, but if you had a multiplier out front, it'll get steeper. If you multiply the x value, it will change the period. If you multiply by 2 with the x, it'll crunch the period down to be half as big. If you multiply x by 3, the period will be a third as big. If you add 5 at the end, it'll shift the whole thing up 5 units. If you subtract something in parentheses, it'll give it a horizontal translation. So the rules work the same way. You just don't have things like amplitudes. So anyway, that's the overall graph. A summary here. Tangent function doesn't have an amplitude. The period is 180 degrees or pi radians. What that means is if you had that b multiplier, if you had something like y equals tangent of b times x, for example, that multiplier out in front of the x, you would divide pi by that value, or 180 by that value, and you would get the new period. Okay, it crosses the axis at 0, basically every 180 degrees, 0, 180 degrees, and so on. And of course, you have asymptotes every 180 degrees as well, setting up that way. So all of those things are the same. So anyway, kind of an overview of the tangent function. I'll do an example or two about graphing them. I'm going to have you graph these a little bit differently. In general, we're really going to focus on the asymptotes and the location of the midline, and that's really going to be what I want to see when you do a graph. But I'll do that in a separate video.